Hello everyone, myself Pavitra Vyas from Department of Information Science and Engineering, Sri Venkateshwara College of Engineering. Today, I'm going to explain about a topic called local replication technologies from a subject called storage area network. What is replication? Replication is a process of creating an exact copy or a replica of a data. Replication can be classified as local replication. Replicating data within the same array or data center is known as local replication. Remote replication. Replicating data at remote sites is known as remote replication. Here, we can just observe the exact meaning of replication. This is the source, and when it undergoes replication, it has created an exact copy or a replica of this source. Local replication technologies. There are mainly two local replication technologies. One is host-based replication and the second one is storage array-based local replication. They are further simplified. For the first one, that is host-based replication, it has two different categories, that is LVM-based mirroring and the second one is file system snapshot. For the second one, that is storage array-based local replication, it is further divided into three. The first one is full volume mirroring and the second one is pointer-based full volume replication and the third one is pointer-based virtual replication. And thus for the second one, that is the pointer based full volume replication, it is further classified into two, that is full copy mode and copy on first access. Whereas the copy on first access is further classified into three. The first one is write to the source and the second one is write to the target and the last one is read to the target. And the third one in the storage array based local replication is pointer based virtual replication, which is simplified into two, that is write to source and the last one is write to target. Now let's look into one by one. Host based replication. In that, the first one is LVM based mirroring. In LVM based replication, the logical volume manager is responsible for creating and controlling the host level logical volumes. And LVM has three components: physical volumes, that is nothing but physical disk, volume groups, and logical volumes. A volume group is created by grouping one or more physical volumes. Logical volumes are created within a given volume group. A volume group can have multiple logical volumes. In LVM based replication, each logical block in a logical volume is mapped to two physical blocks on two different physical volumes as shown in the figure on this slide. Here is the representation of the LVM based mirroring. File system snapshot. File system snapshot is a pointer-based replica that requires a fraction of space which is used by the production file system. It uses the copy on first write principle to create snapshots. When a snapshot is created, a bitmap and block map are created in the metadata of the snap file system. The bitmap is used to keep track of blocks that are changed on the production file system after the snap creation. The block map is used to indicate the exact address from which the data is to be read when the data is accessed from the snap file system. It requires a fraction of the space which is used by the production file system. Here is the representation of file system snapshot. Storage array based local replication. In storage array based local replication, the array operating environment performs the local replication process. The host resources such as the CPU and memory are not used in the replication process. Consequently, the host is not burdened by the replication operations. The replica can be accessed by an alternate host for other business operations. In this replication, the required number of replica devices should be selected on the same array and then the data should be replicated between the source replica pairs. This is the representation of storage array based local replication. Here is the production host and here is the BC host. The source has been connected to the production host, whereas the replica has been connected to the BC host. Next comes the full volume mirroring, which is classified under the previous one. In full volume mirroring, the target is attached to the source and it has been established as a mirror of the source. The data on the source is copied to the target. New updates to the source are also updated on the target. The source is copied to the target. New updates to the source are also updated on the target. After all the data is copied and both the source and the target contain identical data, the target can be considered as a mirror of the source. While the target is attached to the mirror, it remains unavailable to any other. However, the production host continues to access the source. Here is the full volume mirroring figure, which represents exactly what the full volume mirroring does. Next is the pointer based full volume replication. Another method of array based local replication is pointer based full volume replication, which is similar to full volume mirroring. This technology can provide full copies of the source data on the targets. Unlike full volume mirroring, the target is immediately accessible by the BC host after the replication session is activated. Therefore, the data as synchronized and detached of the target is not required to access it. Here, the time of replication session activation defines the PIT copy of the source. Pointer-based full volume replication can be activated in either copy on first access mode or full copy mode. There are two modes. The first one is full copy mode and the second one is copy on first access. Full copy mode. In a full copy mode, all data from the source is copied to the target in the background. Data is copied regardless of access. If access to a block that has not yet been copied to the target is required, this block is preferentially copied to the target. In a complete cycle of the full copy mode, all data from the source is copied to the target. If the replication session is terminated now, the target contains all the original data from the source at the point in time of activation. This makes the target a viable copy for restore or other business continuity operations. Copy on first access. Copy on first access is further classified. The first one is write to the source. In COFA, after the replication session is initiated, the data is copied from the source to the target only when the following condition occurs. The first condition is a write input output is issued to a specific address on the source for the first time. The second one is a read or write input output is issued to a specific address on the target for the first time. When a write is issued to the source for the first time, after replication session activation, the original data at that address is copied to the target. After this operation, the new data is updated on the source. This ensures that the original data at the point in time of activation is preserved on the target. Write to the target. When a write is issued to the target for the first time after the replication session activation, the original data is copied from the source to the target. After this, the new data is updated on the target. The third one is read from target. When a read is issued to the target for the first time after replication session activation, the original data is copied from the source to the target and then it is made available to the BC host. The third one, pointer-based virtual replication. In pointer-based virtual replication, at the time of the replication session activation, the target contains pointers to the location of the data on the source. The target does not contain the data at any time. Therefore, the target is known as the virtual replica. Similar to pointer-based full volume replication, the target is immediately accessible after the replication session activation. This replication method uses COFW technology and it typically recommended when the changes to the source are less than 30%. Write to the source. When a write is issued to the source for the first time after the replication session activation, the original data at that address is copied to the predefined area in the array. This area is generally known as the save replication. The pointer in the target is updated to the point to this data in the save location. After this, the new write is updated on the source. The below diagram shows what the write to the source does. Write to target. When a write is issued to the target for the first time after replication session activation, the data is copied from the source to the save location and then the pointer is updated to the data in the save location. Another copy of the original data is created in the save location before the new write is updated on the save location. Subsequent writes to the same data block on the source or target do not trigger a copy operation. The below figure represents what exactly the write to the target does. Here I complete with my topic. Thank you. Have a nice day.